Okay, so now we're going to move on to some really creative ways to employ linear models so we can extend the ideas and really solve some interesting problems and situations. So the first one we're going to talk about is polynomial regression. So sometimes we have a situation where data points are not linear. That is, they don't fall into a line. They might be a parabola or a cubic. So we could have a quadratic regression model or a cubic regression model, and we might want to fit a set of data to that. So if it's not linear, that it's not a straight line, then maybe a polynomial function might work, like a quadratic or a quartic or a quintic, and you get the idea. So you might have a polynomial function where beta naught, beta 1, x, and the highest degree is the degree at which the polynomial is. So for example, in this case, k is called the degrees of the polynomial. All right, so let's pause your video and see if you can name the degree of the three polynomials that are in the lower right-hand corner. Okay, so the first one has degree 1, the second one has degree 3, and the third one has degree 9. So knowing the degree of the polynomial will play a role. So again, here's the kth degree polynomial regression. We're still assuming that the error random variable is 0 and has a constant standard deviation. So let's go ahead and estimate the parameters. Here's some data about some engineering example with bond strength and the stainless steel substrate or something or other. So if you look at the scatter plot, it does look like it's a quadratic equation. And if you fit a regression line, you can get it, and you get that the y-intercept is 14.521, and you get those other two parameters. And the question is, so this is our estimated for a line, and the question is it difficult to find the coefficients? Actually, it's not. It's very nice way of being able to find the coefficients. So let's show you how. So the answer is no. What we do is we let the first predictor just be x. Now for the x squared, what we do is that's going to be our second predictor. Our x cubed will be our third predictor, and so on, so that x to the kth power will be our x of k predictor. Now if you have any, you're going to go from 1 to k, you're not going to skip any, so you're going to put all that in. So now we just run a multiple regression with these predictors. So for example, here's the Minitib output. Notice that you have here a thickness, but then you also have thickness squared, and that's where this coefficient comes from. So you get then that the equation is 14.521 plus 0.0432323x minus 0.0006001x squared. And so it's going to be quite easy to find out what our equations are, just as long as we set up that equation.